In this video, we're going to discuss some of the concepts and interpretations associated with hierarchical linear models. So, to help to build these concepts and interpretations, think of the terms in terms of individuals within a company. Individuals are going to represent the level 1 model, while company is going to represent the level 2 model. Ultimately, and again at a big picture level, when we're building our hierarchical linear model as we discussed in the previous video, we're really allowing each individual's relationship uh, that's accounted for in level 1, and our hypothetical example was the relationship between an individual's skill or experience and their salary to be different for each company. We're letting each company have a different base pay level and each company having a different skill compensation level where they're able to um, pay you a different amount if you increase your skills or have more experience. We can also use company level independent variables to test how much the company level variable impacts that particular manipulation in terms of base salary or in terms of the skill compensation. It's important to realize that the company level independent variables are going to be called W as opposed to the individual level independent variables, which are going to be called X. So whenever you see an X, you normally think of an independent variable. Now, whenever you see a W, also think of an independent variable, just like X, but now applying to the level 2 model instead of the level 1 model. All right, and with that big picture, let's go on and dive into the interpretation. So I have my level 1 model and my level 2 model. Let's start with the subscripts. I is going to represent which individual we're talking about within the particular company. Now, because this is within the company, these start at 1 with each new company. So company 1 might have an individual 1, but company 2 might also have an individual number 1. J is going to represent which company we're talking about. So if J is equal to 1, we'll be talking about the first company. If J is equal to 2, we'll be talking about the second company, etc. And so if I think of Yij, I'd be thinking of the outcome for the ith individual within the jth company. When you see a sub 0 or a sub 1, the sub zeros are still talking about intercepts and the sub 1 are still talking about the slopes. But as we can see, the sub zeros and sub 1s, sometimes there's multiple of them. So for instance, beta sub 0 is still talking about the intercept component. But now we have within the equation for beta sub 0 j a gamma sub 0 0. Gamma sub 0 0 and gamma sub 0 1, respectively, are both still related to the intercept or the base pay component. What gamma sub 0 0 represents is the fixed intercept or the default intercept across company. Gamma sub 0 1 represents the intercept as it changes with regards to the independent variable W. In our hypothetical case, this will be whether the company is public or private. So gamma 0 0 might be the default intercept across all companies, and gamma sub 0 1 might be the change in the default intercept or base pay based on if the company is public or private. Same thing with gamma sub 1 0 and gamma sub 1 1. Both are part of the beta sub 1 component of the model, which indicates the relationship between the individual's skill and the salary. Gamma sub 1 0, part of that model, is kind of the fixed component of that. That is, across all companies, kind of what's the default salary compensation that's given for skill, so skill compensation, I should say. And gamma sub 1 1 asks, how does the skill compensation change when the company is public or private? So all of the sub zeros and sub ones still represent the same thing. Within the gammas, the first number represent whether it's talking about the intercept or the slope, and the second number of the individual level model, and the second number represents whether it's talking about the intercept or the slope of the level 2 model. So gamma sub 0 0 is the intercept of the excuse me, is the intercept of the intercept model. Yes, gamma sub 0, 1 is the slope from the second level model relating to the intercept of the first level model. So it's the slope that is the change in base pay as the company moves from public to private. All right, let's talk about the first level model specifically. Y sub ij represents, as we mentioned before, the dependent variable for the ith person in the jth company. Similarly, x sub ij is the independent value for the ith person in the jth company, and epsilon ij is the quote-unquote error for the ith person in the jth company, though really it's just the unexplained movement in y that's not explained by the rest of the model. So unexplained variation is another way to represent that epsilon, or think about that epsilon. Unexplained variation in salary that's not explained by any of our variables. As we just talked about, beta 0 still represents the intercept and beta 1 still represents the slope, but now they're a function of j, the company. And this is where what we talked about conceptually comes in, is that different companies may have different intercepts and different slopes. Now, this sounds very maybe abstract, but again, if you think about the intercept, that is the salary when you don't have a skill set or salary with no experience, as base pay. And if you think about, so that's beta 0. And if you think about beta 1 as how much extra compensation you get when your skill goes up, so we'll call that skill compensation. What we're saying is that different companies may have different intercepts base pay. So intercepts, again, the interpretation in our context is base pay, and different skill compensations. And that actually is a much more digestible, I think, way to think about it, where we can look at, do we think different companies should have different base pays? Theoretically, we might say, yeah, that makes sense. Do we think different companies may have different skill compensation levels? Yeah, we might think that makes sense too. So within this context, that's what we mean, is different companies might have different base pays that we need to account for, and different companies may have different skill compensations that we need to account for. And by putting beta sub 0j and beta sub 1j, we're allowing the companies to be different on those. So each company is going to have its own equation that the individuals within that company are going to follow. All right, so let's focus on level 2. And again, we have two models here, one of which is the prediction of the intercept. And again, intercept is kind of a complex sounding term. So if it's helpful for you to think about it in the context, think about base pay. So for beta 0 is a model using the companies to predict the base pay for the jth company. Beta 1 is a model to predict the slope for x. And again, if that sounds complicated, think about it in terms of the context. That's the skill compensation. As you increase in skill, how much are you compensated for that? And different companies might compensate you more or less as your skill increases. So beta sub 1j tries to predict for the jth company, how much is your skill going to increase? Note that each of these have their own intercepts and slope and unexplained variation. So the gammas are interpreted just like the betas are. So gamma sub 0, 0, let's look at just that first equation for now, is the beta 0 value when w sub j equals 0. And again, this sounds rather complex, but let's interpret it in the context. We have y sub ij being our salary. We have x sub ij being our skill level. We have w sub j, that's the company level independent variable, being a private versus public company. And we'll call this public if w is 1 and private if w is 0. And that's important here because when I'm interpreting gamma 0, 0, this is the intercept when wj is 0, which is, again, as we just said, a private company. So this is the expected salary when we have a private company. And just like beta 0 normally, this is also when the skill level is 0. So this is the base pay, I'll call it, for a private company. It's the salary with 0 skill level for that private company. Gamma sub 01 in turn represents the change in the base pay when, in general, WJ increases, but in our case, for it being a binary variable, when we become a public company. So how much did your base pay change when we're looking at public companies instead of just private companies? That's what this gamma sub 01 represents. And again, more generally, WJ could be a continuous variable, and we could look at for a single unit increase in WJ, what's the change in base pay in our case. But again, this is assuming X, the skill level is 0 still. For gamma sub 1, 0, this is our beta 1. And when I say this is the interpreted as beta 1, and earlier I said interpreted as beta 0, I mean it quite literally. Beta 1 is how much does the salary change when your skill goes up by 1 point. In this case, gamma 1, 0 is that exact interpretation, but when the level 2 independent variable is 0. So in this case, for private companies. Saying that all together, gamma sub 1, 0 in our hypothetical example is the average increase in salary when skill increases by a single point when WJ equals 0, so for private companies. And in turn, gamma sub 1, 1 represents the change in that skill composition when we're looking at public companies, or more generally when WJ increases. So gamma sub 1, 1 would be how much the salary increases for a single unit increase in skill from private to public company. So a private company may compensate a single unit increase in skill at one rate. Gamma sub 1, 1 says how much more or less do public companies compensate a single unit increase in skill. That's the interpretation of gamma 1, 1. All right, now let's move to the independent variables. There are two independent variables in this model. X sub ij represents the X value, which is an independent variable for the ith participant in the jth group. And as we said before, W sub j represents the W value. That's an independent variable at level 2 for the jth group. And we have an example here in the slides, but I prefer the example we've kind of been rolling with where the independent variable is skill rather than age. I think that's a better example. It's important to realize, though, that these independent variables are sometimes called fixed effects within the models contrasted with our random effects. All right, within these models, it's important to consider the last terms, and these are actually some of the most important things in hierarchical linear modeling. And we've always considered epsilon and u to be error, but again, more accurately, these represent unexplained movement. So u sub 0j represents the unexplained movement for company j in the intercept, and again, in our context, we're thinking in base pay. So let's look at beta sub 0j, and we're letting each company have its own base pay, and this is really important. So please pause the video or catch your breath if you need to. If you've been doing these videos in a marathon, maybe you do need to, but this is quite important. The base pay, the kind of default starting value for all of the companies is this gamma 0, 0. And then we might have different levels for private and public. That's the gamma 1, 0s to account for that. But still, companies may be different. And the level 1 equation, we still have a customized equation for every company. That's still going on. And how we do that is this u sub 0j term. The u sub 0j says, yeah, not every company, even within the public or private sectors, may have the exact same base pay. So we still have to let companies have their own base pay. And that's not really explained by the independent variable in our level 2 model. So U is the unexplained movement in base pay for each of the companies. That is, as companies differ from the public or private other companies, U lets that happen and lets us include that information in the level 1 model. Now, as we talked about for base pay, the same thing can happen with skill compensation. Skill compensation, if I look at the second level 2 equation, the gamma 1, 0 represents the default skill compensation for all the companies. Gamma 1, 1 lets me change that for private and public, but still that might not be specific enough to account for all of the movement in skill compensation among companies. And the U sub 1j allows us to let each company have their own skill compensation, um, even if it's not accounted for in those other effects. Epsilon sub ij is still the unexplained movement in the dependent variable, and we still tend to consider this error. But again, all it is unexplained movement. Taken together, these are called random effects. So in the U sub 0j and the U sub 1j, these are considered to be random effects in that we're letting each company have its own value. Whatever that value is, we're letting each company have its own value. Now we are trying to see with the W sub j what variables at the level 2 may be related to that value. But even if we can't predict it perfectly using level 2 independent variables, we're still going to let each company have its own custom value for those level 1 equations. And that's why these U's are so important, is they're what let each company have its own value for the slopes and intercepts, or in our example, they're what let each company have its own value for the base pay and the skill compensation. Now, I mentioned earlier that there are two different forms that we can use, the hierarchical and combined form. We've been talking through the hierarchical form, and again, when appropriate, I find it to be much easier to interpret and understand what's going on. We had the level 1 component, and this is just what we saw earlier, not color-coded, but what we saw earlier, and the level 2 series of equations. The combined form, we literally just take, in our example of the hierarchical form, take that beta sub 0j, and that has an equation. We just plug that equation in for beta 0j in the very first equation. And we take the beta 1j in the third equation and take the right-hand side of that and plug it in for beta 1j in the first equation. And we end up with our first combined form. Now, again, the combined form is just a big, long equation with all of these components written into it. But sometimes you'll see it rearranged. I believe in the Tabachnik and Fidel book, we have it rearranged to be written as this form. And all that happens here is we multiplied the x through and then rearranged the terms. So this is our combined form, or a couple of different combined forms. Now, when interpreting a combined form, again, combined and hierarchical forms are the same. So in interpreting a combined form, these interpretations actually ultimately lead to the same thing. But when looking at the combined form, sometimes you think about it a little bit differently. So as we talked about earlier, gamma 0, 0 is the intercept. It's when x and w are both 0, and x and w are both just variables. X is a level 1 independent variable. W is a level 2 independent variable. Gamma sub 1, 0 is the slope for x when w equals 0. Now, why is it when w equals 0? What's the slope for x when w equals 0? Because the x and w have an interaction term. So if you look at gamma 1, 1, you see that there's an interaction between w and x. And so the independent variable of x is interpreted now when w equals 0, just like all of our other interaction terms in regular regression. The slope for w is interpreted when x equals 0. That's gamma 0, 1. And again, we're kind of leaning on those interaction terms in regression. I'll say the slope for x is not interpreted at w equals 0. If that interaction term weren't there, it'd be interpreted after accounting for w, or after all the w's. So that is an artifact of there being an interaction term between these two variables. Gamma sub 1, 1 is the slope for x adjustment based on w, or vice versa. Again, the interaction between x and w. U sub 0j is the intercept adjustment per group. So how are we letting base pay vary, or the fact that we are letting base pay vary depending on company. And then U sub 1j, you could look at this and say we're letting the skill compensation vary based on company, and that's what U sub 1j is representing in this equation. Similarly, epsilon sub ij, just as it is before, is that individual error or the piece of the dependent variable that is yet unexplained by the rest of the model. All right, so in this video, we talked through some higher level concepts as well as getting into some nitty gritty on interpretation. In the next video, we're going to talk about how we can build some different models that we could end up using when modeling this practically.